In our video today, we're going to start looking at what a function is. So this will just be the first part of our functions unit. We're going to start by examining the coordinate plane. Another term that you'll hear for this is a graph or an XY grid. There's lots of different names that are related to that, but they all have similar features and are just different names for the same thing. So a coordinate plane is broken up into 4 different quadrants. Think of quad, like a quadrilateral has 4 sides. There are 4 quadrants. They're named as quadrant 1, 2, 3, and 4, but as you'll see, the formal name for these is written in Roman numerals, so quadrant I, double I, triple I, and IV. So that's what those are labeled as. Below them, we see some parentheses with pluses and minuses in them, and that helps us decide what sign we have when we're talking about our coordinate plane. So before we get into the signs, let's look at all these different parts. Our x-axis is this horizontal line that is going across our graph. So the x-axis will always be horizontal. Our y-axis cuts through the x-axis and goes vertically across our graph. So the y-axis will always be vertical. Where these two axes meet, so where the x and y come together, is right here at the center of our graph, but we call that the origin. We always start plotting points from the origin. A point can be anywhere on the plane, and it will be written as an ordered pair, and we'll see it in parentheses as x, comma, y. Now, it won't just be the letters. They'll have number values, and when they're both positive, you'll be in quadrant 1. When the first number is negative and the second number is positive, you'll be in quadrant 2, and so on. So let's try and look at a couple of points like this. So for example, if I were to look at the number or the point -2, 3, I would start on my origin and I would go 2 spaces to the left and 3 spaces up. I've ended up in quadrant 2 with the point -2, +3. That's because I've gone to the left for my x value. So on my x-axis I went left, it was negative. And then on my y-axis I went up because that was a positive value. So left and down will mean negative, but up and right will mean positive. So those are going to be the directional signs that we're going to be using. So in our next point that we'll try, let's look at where 2, 2 would be. So if I say 2, 2, those are both positive. So on my x-axis, I'm going to go 2 to the right, and on my y-axis, I'm going to go 2 up. So that means that I've landed in quadrant 1. My x was +2, and my y was +2. So I went right 2 and up 2. In the next one, let's try 5, -2. So I'm going to count 5 spaces to the right because the first number I said was 5, that's my x value, and it's positive. My -2 is my y value, so I'm going to go down 2 spaces. So I've ended up in quadrant 4 here. This is now where my point 5, -2 is. My x was positive, so I went to the right, and my y was negative, so I went down. Let's try to find a point in our third quadrant. Let's say I'm going to plot a point about right here. If I put a point here, I'm going to start at my origin to figure out where I ended up. I went 1, 2, 3, 4, 5 boxes to the left. So that means my x value is -5 because I went horizontally left. That's a negative in my x value. Then for my vertical movement, I went down 1 box. So that means my y value is -1. So the point that I created in quadrant 3 there is -5, -1. So notice that all the points that we just found together in our graph correspond to those signs that were over here. So in quadrant 1, both of our x and y's were positive. In quadrant 2, we had a negative and then a positive. In quadrant 3, we're negative, negative. And in quadrant 4, we're positive and then negative. Notice that in all of these, we always started from the origin and we wrote our points as x and then y. We want to start with x every single time we write it as an ordered pair on the graph. So now that we've reviewed where points are on the coordinate plane, we want to look at how we can see them in a relation. A relation is just going to be a set of ordered pairs, so more than one point. So kind of like what we drew up top on our graph when we plotted those 4 points together. So we're going to change from seeing these points as just 4 sets of ordered pairs and copy them into this table. Remember that in an ordered pair, we always write the points in the order x and then y. So that means that the very first number you see in a set of parentheses will be your x value. So notice in the first one it said 2, 0. That means my x value is 2 and the y value with it will be 0. On the graph, we'll start at the origin. I want a positive x, which is 2, and my y value is 0, so I'm not going to move it all vertically. That means my first point will be here at 2, 0. In the next point on our list, we were given 3, -3. So again, our x value is just 3, and the y value is -3. So to write it in the table, we just transfer our x to our first column and our y to our second column. We'll write it on the graph by finding this point. So start at your origin, 0, 0, right at the center of the graph. My x value is +3, so I'm going to count 3 spaces to the right, and my y value is -3, so I'm going to count 1, 2, 3 spaces down. That gets me to my point 3, -3. The next point in our list was 3, 6. So our x value is 3 and our y value is 6. We go 3 spaces to the right from the origin and 6 spaces up from that spot. And that's where we'll plot 3, 6. Our last point in the table, or in the list, was -5, 6. So remember, our ordered pairs always go x and then y, so that means the x value I'm plugging into the table is -5, and the y value that goes with it is 6. So now we have our -5 on x, so we're counting 5 spaces to the left from the origin, and then we're going 6 spaces up from there. So our last point is -5, 6. So you can transfer your points from a list like this, you can put them into a table, and you can put them onto the graph. Every single time you do that, you will always still be relating those x's and y's. Seeing all 4 of these points together, either in a list, on a table, or on the graph, makes them a relation. So now we're going to look at a special type of relation. That's going to be called a function. A function is a relation in which every input x has only one output y. So if you notice back in our first relation that we did together, we had an x value of 3 and it showed up twice. In this table, 3 had an output of -3, but it also had an output of 6. So in a function, that won't happen. When we plug in an x value, we'll only get one y value out. We're never going to get more than one y value with an x value. So when we look at this set of ordered pairs, we're going to plug them first into the table and then plot them on the graph. So I see -2, 2 is my first point. It's written as an ordered pair, so remember x is the first number and y is the second. So in this specific point, we had -2, 2. Then we had 0, 4. Then we have 1 and 5. And our last one is 2 and 6. So remember, we're looking to see if this is going to be a function, every input should have only one output. Notice that none of our x values here are repeating this time. So that means that every single input, every x value that we plugged in, we only got one individual y value out with it. So nothing was repeated, therefore this will be a function. To put this on the graph, we're just going to plot our points. -2, 2 is our first one, so we're going to start at the origin, and we're going to go 2 spaces to the left and up 2 on our y-axis. So our first point here is -2, 2. Then we have 0, 4. So since 0 is my first number, that's my x value. I'm not moving left or right when it's 0. I'm just going to stay right here in the center. But my y value is +4, so on the y-axis, I need to go up 4 spaces. So my point 0, 4 actually ends up on the y-axis here. The next point I have is 1, 5. So for 1, 5, we're going to start again at the origin. We're going to look for our +1 on our x-axis, so 1 space to the right on the x, and then up 5 spaces from there. So that means my point 1, 5 will end up right here. And the last point we had was 2, 6. So we start on our origin, we count 2 spaces to the right, and then we count up 6 spaces from there. So notice here how when we see our function, we can kind of notice that there's a pattern starting to happen. We've got these 4 points that are slowly increasing on the graph, and if you were to connect them, they can make a line there. Whereas before, when we had our relation that we were studying, they wouldn't really make a line. If I tried to connect all of them, right, they aren't making that nice straight line like our function did. And we can see that these 2 points are actually on a vertical line together, meaning that that's not going to be a function. And we'll look a little bit more at that as we continue in our functions unit. We're going to go ahead and look at what the difference between domain and range is. So using everything we just talked about with our set of relations, or our set of ordered pairs to create a relation and to create a function, we can specifically look at domain compared to range. So the domain is going to be the set of all inputs or x values in a function. So that's going to be all of the numbers that come first in your ordered pair or in your x column of your table. So here, we'll look for our x values to find our domain. Our range is the set of all outputs or y values in a function. So the y values that come from those x values that were put in get us the outputs, and that'll be part of our range. So when you're asked to identify the domain and range, you're saying all the possible x and y values for the function. Domain, like we said, is always going to be our x values, so we can write them as -6, we can write it as 6, 5, and our last number is 7. I've listed all of my x values here. One thing that you may want to do is write them from least to greatest, but it's not required. Then for our range, we are looking at all of the possible outputs, so the y values that are related here. So we have 4, 4, 3, and 6. So notice here that we had some outputs that were repeated, but our inputs never repeated. In a function, the inputs are not allowed to repeat. You don't want to repeat your x, but it's okay to repeat a y value or output as part of your range. So this is still a function, and we've now identified the domain and range of this function. You can do the same thing from a set of ordered pairs rather than seeing them in a table. You're still going to look for your x's for your domain. Remember that in an ordered pair, x always is the first number. So these numbers will be part of our domain. And our range will always be our output, our second number, so the y value in our functions. So once we've identified those, we can list them. And this time I'm going to list them from least to greatest. So -3, -1, 0, and 1. And for our range, notice I have 3, 2, 3, and 2. So just to put them from least to greatest this time, I'm going to put 2, 2, 3, 3. Again, it doesn't matter if it's in least to greatest, we'll accept it either way. The biggest thing that we want to keep in mind here is that our inputs are our x's and they go with our domain. Same with our range is our output as our y's. One of the ways that we can try to remember all these new vocab words together is to think of them in little pairs. So inputs go with outputs. Domain and range come together in a pair. And x's and y's in our ordered pairs are always together. So we've kind of got these pairs of two things. One of the ways that you can try to remember is by using your alphabet. So I comes before O, just like D comes before R, and X comes before Y. So inputs, domain, and inputs, domain, and X are always going to be related to one another because they're out of their two opposites there. They're always first in the alphabet. Whereas output, I is before O. So O is the second letter. Range, R comes after D, and Y comes after X. So all of those are the second part. So if you're kind of struggling to remember which goes with which, the inputs always come first and outputs will always come second. Think about your alphabet there to help you remember what order to put them in. And next up, we're going to be evaluating functions. So when given an input x, we can evaluate the function rule to solve for the output value y. And we've already done evaluating expressions this year. This is just going to look a little different because now we're going to be evaluating an equation for a specific x value. So notice that we are given this function rule y equals 5x. So this is what we can call an equation, or in this case a function rule, because this is what is going to get us all of our y values depending on what x value you enter. So our first x value that we want to use is -3. So y is going to equal 5x. Well, remember 5 and x are sitting next to each other, so we know they're multiplying. And we are just going to replace the x value with our -3, since that's the x that it just asked us for. So to get this first y value point that we're looking for, we're replacing our x value with -3. Whatever we get out of that will be the y value that is related to it. So we just have to do our math. 5 times -3 is -15, so that means the y value when x is -3 will be -15. In our second one, we're going to keep using the same rule, so y will come from multiplying 5 times our x value. Our next x value is -1. So again, to get that y value that we're looking for, we're just replacing the x value in the table with an x with that same number here in our rule. 5 times -1 will get us -5. We're going to repeat the process for our last two x values. We're going to keep multiplying each new x value by 5 since that was our function rule. We get an answer for this next one of 5 times 0 is 0, and 5 times 5 for the last one will be 25. So all we did is just multiply each x value by 5 to get the y value that it was equal to, since our function rule told us originally that y comes from taking 5 times x. You can do this with any x value that you want and replace the x's with whatever value you want to plug in, and you'll get a y value. We'll give you these x values to practice right now, but you could theoretically put in any number that you wanted in x to see what the answer is for y then. In the next one, we're going to do the same thing, but you'll notice that there's a little bit of an extra step here. So our x value is still going to be a number that we're entering into our rule. That's going to get us y, since y is equal to this whole thing. So we're going to do the same process, but notice there's an additional step that we didn't have last time. This time our function rule says that y comes from doing 2 times x and then -1. So I need to do 2 times -1 in the first one, and then I'm going to subtract 1 since that's part of my function rule. So y equals 2 times -1, which was our x, minus 1. So we need to use GEMDAS here. So we've got multiplication and subtraction. That means we have to multiply before we're allowed to subtract. 2 times -1 is -2, minus 1 gets us -3. So we took our multiplication first and then subtraction to get our answer of -3. We're going to repeat the same thing with the rest of our x values to fill in the rest of our table. So we'll use our y value, or y equals 2 times our x value of 2 this time, and then we'll need to subtract 1. So remember, GEMDAS says multiply before you subtract. 2 times 2 is 4, and 4 minus 1 is 3. So we got a y value of 3 when x was 2. Go ahead and try the last two, and check the screen when you're ready. For these last two, y comes from multiplying 2 times our x value again and subtracting 1. We're first plugging in an x of 3, so 2 times 3 is 6, and 6 minus 1 is 5. In the last one, 2 times 4 is 8, and 8 minus 1 is 7. So that's going to get us all of our x and y values that go together for what we were solving for in this table. Again, you could keep going. You could plug in 100 if you really wanted to and figure out what your y value would be there. There's no limit to how many you can plug in here. All right. In our last example for today, we are going to list the ordered pairs that are on the graph. We're going to show our domain and our range, and then we're going to decide whether this is a function or not. So let's first find our points. The first one here that's on the very left, I see, is going to be negative because we went 1, 2, 3 spaces to the left on our x value, or our x-axis first. And then we went up 2 boxes on the y-axis. So that's going to be -3, +2. The next point that I can see is right here. I noticed right away that it's on the y-axis, meaning we did not go left or right on the x-axis. So we moved nothing on the x-axis, which is a 0 for my x value. However, I did go upwards by 7 spaces, so my y value will be 7. The next point is right here, and I can see that I have gone 2 spaces to the right, so my x value is 2, and then I went down 4 spaces, so 2, -4. And remember, I'm always starting from the origin to find these. In my last point here, I went to the right and then up from the origin. So it looks like we moved over 1, 2, 3 spaces to the right, and then we went up 7 spaces. So we have 0.37. So remember domain. Domain always comes from our x value or our inputs. Those are always that first letter in the alphabet between the pairs. So x's go with domain. So we're going to fill in all of our x values here. We have -3, 0, 2, and 3. Our range comes from all of our outputs or our y values. So those are the second thing. We're going to list them in our range list, so 2, 7, -4, and 7. So is it a function? Remember, we have to look for, do any of our inputs repeat? Because the definition of a function said it's a relation in which every input or x value has only one output. So we check our x's. Did any of them have a repeating x value to get a different output? -3 only showed up once, 0 showed up once, 2 showed up once, and +3 showed up once. So since none of our x's repeated, yes, this will be a function because every input has only one output listed.